Quadratic and absolute value transformations. In this concept, we're going to look at taking a function and transforming it. You hopefully remember that term from geometry. We, however, will not be able to transform Shrek into the Hulk. A parent function is the simplest function of a family of functions that preserves the shape of the entire function. So we have tons of parent functions in math. Here's just a few. And each of these graphs, each of these functions can be taken and transformed by moving them up or down or left or right, or stretching them or compressing them or reflecting. So there's a lot of functions we could focus on, but we are just going to focus on these two functions right here, absolute value and quadratic. Okay, so first of all, the names are quadratic and absolute value functions, and the equation for the quadratic function is just x squared, and our equation for the absolute value function is the absolute value of x. So those are two bars on each side of the x, just straight lines down. And just to recall, an absolute value function takes a number and makes it positive. So if we had the absolute value of 2, the answer would just be 2. The absolute value of -2 would be 2. So whatever is in the inside, it either makes it positive or just keeps it positive if it already was. The graphs for these two functions actually go through the same three points. The only difference is a quadratic graph is a U shape and absolute value is a V shape. So it really does matter how you draw these. The 3 points that these go through are the origin, 0, 0, the point 1, 1, and the point -1, 1. When you graph these for me, you're going to need to make sure that you have these 3 dots on the graph so that I can see them. Okay, now we're going to look at what the equation would look like if we move our graph left or right. So starting with quadratic, if we were to move our graph in a horizontal, left or right, we would have a value inside with the x. So notice that it's inside parentheses, and it's with the x. So I always want you to remember that that's what goes left and right. So let's look at 2 examples. First of all, if we had a -5 in the parentheses, that would go right 5. Now, you're probably saying, hold on, a -5, that seems like it should go to the left, but that's not the case. Right is always a minus on the inside. If we have a +7 on the inside, where our h goes, then that's going to go left. So this is the one time in this entire concept that I think it's not what you would think. It's counterintuitive. Over here on the left side, I've put a plus sign under the word left and a minus sign under the word right. That might be a good thing for you to reference back at. We have pretty much the same thing going on over here with our absolute value. So again, inside the absolute value bars, we've got x minus h. If we have an example where we have x minus 2 in the absolute value bar, that's going right 2. Minus is right. If we have, say, x plus 6 in the absolute value bars, that would be left 6. Next, we're going to move on to up, down. This one is much more intuitive, and up is going to be a plus, and down is going to be a minus. So for our quadratics, we've got a k value here. So it's x squared plus k. Notice that k is on the outside. It's not inside the parentheses with the x. So if we have x squared plus 7, that would be up 7. And x squared minus 9 would be down 9. For our absolute value, same idea going on. Outside of the absolute value, we have our k. So if we have absolute value of x plus 3, that's up 3. Or absolute value of x minus 4, that's a down 4. Next, we have reflection across the x-axis. With this one, we're just putting a negative out front of our equation. Next, we're going to introduce an a value that shows us whether a graph has stretched or compressed. Any value for a that is bigger than 1 will be a stretch, and any value that's between 0 and 1 will be a compress. Make note of that over on the left side. Okay, so for quadratic equations, we're going to have an a out front of our equation. If we have 5x squared, that would be a stretch by 5. Or if we had 1/3 x squared, that would be a compress by 1/3. For absolute values, exact same idea. We have an a out in front of our function. Again, if it's, say, a 6, then it would be a stretch. Or a 2/5, that would be a compress.